Hello friends, this is Rashmi Singh and welcome to my channel Unraveling Science. Solutions for Is Matter Around Us Pure? Class 9 Chapter 2. Questions in the chapter. What is meant by pure substance? The substance which is composed of only one type of particle is called pure substance. All the constituent particles of a pure substance have same chemical nature. It can be classified as elements or compounds. List the point of differences between homogeneous and heterogeneous mixtures. So the difference between the homogeneous and heterogeneous mixtures are homogeneous mixtures have uniform composition and heterogeneous mixtures have non-uniform composition. Homogeneous mixtures have no visible boundaries of separation between its constituents. Heterogeneous have visible boundaries of separation between its constituents. Constituents cannot be separated by simple physical means in homogeneous, but in heterogeneous they can be separated by simple physical means. Differentiate between homogeneous and heterogeneous mixture with examples. So the difference between homogeneous and heterogeneous mixture is same as in the previous question. Example of homogeneous mixtures are salt in water, sugar in water, copper sulfate in water, iodine in alcohol, alloy and air, etc. Examples of heterogeneous mixtures are sodium chloride, iron fillings, salt and sulfur, oil in water, chalk powder in water, wheat flour in and water, milk and water. How are sole, solution and suspension different from each other? So the difference between sole, solution and suspension are: first type of mixtures. Sole is a heterogeneous mixture, solution is homogeneous and suspension is also heterogeneous mixture. Size of particle. Sole particle size is 10 to the power minus 7 to minus 5 centimeter. Solution is less than 1 nanometer and suspension more than 100 nanometers. Tyndall effect. Exhibited by sole, not exhibited by solution, may or may not be exhibited in suspensions. Appearance. Soles usually glassy and clear, solutions unclouded and clear, suspension cloudy and opaque. Visibility. Soles are visible with an ultra microscope, solutions not visible, suspension visible with naked eye. Diffusion. Diffuses very slowly, soles, solution diffuses rapidly and suspension do not diffuse. Stability. Soles are pretty stable, solutions are highly stable and suspensions are unstable. Settling. Soles get settled in centrifugation, solution do not settle, suspension settle on their own. Examples of sole are milk, blood, smoke. Solutions are salt and sugar solution and suspension are sand in water, dry, dusty air. To make a saturated solution of 36 grams of sodium chloride is dissolved in 100 grams of water at 293 Kelvin. Find its concentration at this temperature. So the mass of solute NaCl is 36 grams here. Mass of solvent water is 100 grams. So mass of solution will be sodium plus water, that is 136 grams. So concentration is equals to mass of solute upon mass of solution into 100. Now putting the values, we get 36 upon 136 into 100, that will be equal to 26.47%. Classify the following as physical or chemical changes. cutting of trees, melting of butter in a pan, rusting of almirah, boiling of water to form steam, passing of electric current through water and water breaking into hydrogen and oxygen gases, dissolving common salt in water, making a fruit salad with raw fruits, burning of paper and wood. So the classification of the following in physical and chemical changes are as follows. So the physical changes are cutting of trees, boiling of water to form steam, melting of butter in a pan, making of fruit salad with raw fruits, and dissolving common salt in water. Example of chemical changes: rusting of almirah, passing of electric current through water and water breaking into hydrogen and oxygen gases, burning of paper and wood. Try segregating the things around you as pure substances and mixture. So the pure substance around us are water, salt, iron, diamond, etc. And mixtures are soil, salad, air, and steel, etc. Back exercises. Which separation technique will you apply for the separation of the following? Sodium chloride from its solution in water, we use the technique of evaporation. For ammonium chloride from a mixture containing sodium chloride and ammonium chloride, the answer is sublimation. Separation of small pieces of metal in engine oil of a car, technique is filtration, centrifugation, or decantation. For separating different pigments from an extract of flower petal, process is chromatography. For separation of butter from curd, we use centrifugation. For oil from water, we use separating funnel. For tea leaves from tea, we use filtration technique. For iron pins from sand, we use magnetic separation. For wheat grains from husk, we use winnowing. For fine mud particles suspended in water, we use again centrifugation. Write the steps you would use for making tea. Use the words solution, solvent, solute, dissolve, soluble, insoluble, filtrate, and residue. First, take a cup of water in the container as solvent and heat it. Then add sugar in it, which is solute. Heat it till all the sugar dissolves. You will get a solution of water and sugar. Sugar is completely soluble in water. Now add half a teaspoon of tea leaves, which are insoluble in water. Boil the content, add milk, which is also soluble in water. Boil again. Filter the tea with the help of a strainer. The tea collected in the cup is filtrate and the tea leaves collected on the strainer is residue. Pragya tested the solubility of 3 different substances at different temperatures and collected the data as given below. Results are given in the following table as grams of substance dissolve in 100 grams of water to form a saturated solution. You can see the table here. What mass of potassium nitrate would be needed to produce a saturated solution of potassium nitrate in 50 grams of water at 313 Kelvin? Mass of potassium nitrate to produce the saturated solution of potassium nitrate in 100 grams of water at 313 Kelvin is 62 grams. So the mass of potassium nitrate in 50 grams of water at the same temperature will be 62 into 50 upon 100. That will be equal to 31 grams. Pragya makes a saturated solution of potassium chloride in water at 353 Kelvin and leaves the solution to cool at room temperature. What would she observe as the solution cools? Explain. Some soluble potassium chloride will separate out in the form of crystals at room temperature because the solubility of potassium chloride will decrease with the decrease in temperature. Find the solubility of each salt as 293 Kelvin. Which salt has the highest solubility at that temperature? The solubility of salts at 293 Kelvins are potassium nitrate 32 grams, sodium chloride 36 grams, potassium chloride 35 grams, ammonium chloride 37 grams. Ammonium chloride has the highest solubility at 293 Kelvin. What is the effect of change of temperature on the solubility of the salt? The solubility of salt increases with increase in temperature. Explain the following giving examples. A saturated solution. A solution in which no more solute can be dissolved at a particular temperature is known as saturated solution. For example, aqueous solution of sugar, no more sugar could be dissolved at room temperature. Pure substance. A pure substance is a substance consisting of a single type of particles, that is, all the constituent particles of the substance have the same chemical properties. For example, water, sugar, salt, etc. Colloids. A colloid is a heterogeneous mixture whose particles are not as small as solution, but they cannot be seen by naked eye. When a beam of light is passed through colloids, then the path of the light becomes visible. For example, milk, smoke, etc. Suspension. Suspension is heterogeneous mixture in which solids are dispersed in liquid. The solute particle in suspension do not dissolve but remain suspended throughout the medium. For example, paints, muddy water, chalk water mixtures, etc. Classify each of the following as homogeneous or heterogeneous mixtures. Soda water, wood, air, soil, vinegar, filtered tea. Homogeneous mixtures are soda water, air, vinegar and filtered tea. Heterogeneous mixtures are wood and soil. Note, the pure air is homogeneous mixture but the polluted air is heterogeneous mixture. How would you confirm that a colorless liquid given to you is pure water? Every pure liquid has a characteristic boiling point. Pure water has a boiling point of 100 degrees centigrade. If a given colorless liquid boils exactly at 100 degrees, then the given liquid is pure water. If it is slightly above or below 100 degrees, then the given liquid is not a pure water. Which of the following materials fall in the category of pure substance? A. Ice, milk, iron, hydrogen chloride, calcium oxide, mercury, brick, wood, air. So the pure substances here are ice, iron, hydrochloric acid, calcium oxide and mercury. Identify the solution among the following mixtures: soil, seawater, air, coal, soda water. So the solution here are seawater, air and soda water. Which of the following will show the Tyndall effect? Salt solution, milk, copper sulfate solution, starch solution. So the Tyndall effect will be shown by milk and starch solution. Classify the following into elements, compounds and mixtures. Sodium, soil, sugar solution, silver, calcium carbonate, tin, silicon, coal, air, soap, methane, carbon dioxide, blood. So out of these, the elements are sodium, silver, tin and silicon. The compounds are calcium carbonate, carbon dioxide and methane. And mixtures are soil, sugar solution, coal, air, blood and soap. Which of the following are chemical changes? A. Growth of plant, rusting of iron, mixing of iron fillings and sand, cooking of food, digestion of food, freezing of water and burning of candle. So the chemical changes is taking place in growth of plant, rusting of iron, cooking of food, digestion of food and burning of candle. Thanks for watching. Please do like, share and subscribe.